Hello viewers, welcome to the official YouTube channel of the Institute of Pharmacy, Assam Don Bosco University. If you have not subscribed to this channel, please subscribe it and also share this video with anyone who may need it. So today we will be discussing Unit 3, that is alcohols, from Pharmaceutical Organic Chemistry 2, having subject code BP202T, and this is from B Pharm second semester. So alcohols as we know, it has the general formula ROH, where R can be any alkyl group. Now what is the relevance of studying this unit? So the relevance of studying this unit is that we can get an idea about alcohols because it is used as a universal solvent in many of the processes. So as a universal solvent it is used, so therefore we need to know its chemistry very properly. Another thing is that it is also used as a preservative and as a stabilizer in many of the drug formulations. Also it is used as disinfectant, antiseptic and so on. And also if we see many of the drug molecules, they have the hydroxyl group in their structure. So studying their chemistry helps us understand their stability and also their synthesis pathways. We can understand properly if we have an idea of this of the chemistry of alcohols. So let us proceed. If we see, then alcohols, it can be first classified. So there is a way to classify it. The first way is on the basis of the number of OH groups which are present. So on that basis we can have monohydric alcohols, dihydric, trihydric and polyhydric. So monohydric alcohols, they contain one OH group. So for example, if we see, we can take this example. If we see, this is of propanol. So this has only one OH group, so therefore it will fall under your monohydric alcohol. Now if we see another example for dihydric alcohol, then we can have, let's say for example this. So here we see it has two OH groups, so therefore we can name it as 1,2-ethanediol. So this becomes 1,2-ethanediol. So this is an example of a dihydric alcohol. Similarly, if we see for trihydric, then we can take this as an example. We will put one OH group here and another OH group here, and then another one here. We have to remove this H. So this becomes 1,2,3 propan-triol. So this will be a trihydric alcohol. So this is one way to classify alcohol. Another way to classify is based on the nature of the carbon atom bonded to the OH group. So on this basis we can have primary alcohol, secondary alcohol and tertiary alcohol. So if we see one example, we will include one alkyl group here, and then hydrogen. So this will be an example of a primary alcohol because we have only one alkyl group here. So if it has two alkyl groups, then this will become the secondary alcohol. And if we have three alkyl groups, then we will get a tertiary alcohol. So this is again another method on which the classification of alcohols can be done, that is primary, secondary and tertiary. Now let's discuss about the various methods of preparation of alcohols. So the first method is the hydration of alkenes. So for this purpose we react an alkene with concentrated sulfuric acid. So if we see an example, for example we can take ethene. So let us take ethene here, okay, and we will react with sulfuric acid. So this will give so this is one example. Next, okay, let me change this, sorry. So this reaction proceeds in 2 steps. So first step we will get ethyl hydrogen sulfate. For example, if we take ethene, and then simultaneously from here we will get our ethyl alcohol. So this will be our product, okay, from this alkene. This will be the ethyl alcohol and this will be the ethene. So this is one of the method for preparation of alcohols. Let's see other methods. So the next method is by the hydrolysis of alkyl halides. So for this purpose we will use sodium hydroxide or potassium hydroxide. So if we see the general reaction, then we have an alkyl halide here, and then we will have NaOH. So this will simply give us a primary alcohol and NaX. So whatever halogen you are using, oh I'm sorry, this should be X, since we are talking about alkyl halide. So we have our alkyl halide here, and then we will get our alcohol. Next is by hydrolysis of carboxylic esters. So for this, let's take an ester, and then water will be there, since we are using a dilute solution of an alkali or a mineral acid. So this will give us an acid, carboxylic acid and alcohol as our product. Next is by reduction of carbonyl compounds. So if we take one example, then we have this carbonyl compound. So here again we get our alcohol as the product from carbonyl compounds. So this is a reduction, this is with the help of a proper reducing agent. Next is the most common method, or which has been followed for centuries, that is for the preparation of beverage. So in the beverage industry this is particularly used, where we see sugar, okay, or molasses, okay, it undergoes the process of fermentation to give glucose plus fructose. Glucose and fructose is present, and from this glucose and fructose we get alcohol by the process of your fermentation. So this is one of the most common method in which yeast is used, and we also get carbon dioxide as the byproduct in this case. So sugar, particularly our glucose and fructose, is commonly used. So alcohol, if we see, it occupies a central position in organic chemistry because they can be prepared from a wide range of compounds. So ether, aldehyde, ketone, alkene, carboxylic acid, ester, alkyl halide, as we have seen in the previous examples. From all of this, alcohols can be derived. So they occupy, or they are considered to occupy a central position in organic chemistry. So we'll proceed with some reactions of alcohol. So alcohol, they behave as weak acids. So acids, they tend to release H plus ions, and alcohols are considered as weak acid. So let's see the first reaction. The first reaction is with alkali metal. So we can have, like for example, sodium. So if we take one example, we have an alcohol and then we have sodium here, sodium metal. So this sodium metal, it reacts to form sodium alkoxide. So we will have our sodium alkoxide, and in this process hydrogen is released. So we have our sodium alkoxide here, and then we have our alcohol here. So this is the first reaction. The other reaction is the action of metal hydride. So we will see one example. We have an alcohol here, and then we have a metal hydride. So in this case also, our hydrogen gas will be released. So we have these two reaction. We'll see another two reaction, very common. The next reaction is very common, which is used for identification purpose also. For identification purpose of alcohol also it is used. So in this we have carboxylic acid, which reacts with alcohol, carboxylic acid which reacts with alcohol to give a fruity smelling compound. Okay, we get a fruity smelling compound which also helps in the identification. And this, okay, I will show with the reaction. So we have a carboxylic acid here and alcohol. So this undergoes esterification, and subsequently we get our ester. This is the ester that we get, and water molecule. So this is very pleasant smelling and helps in the identification of alcohol. The next is dehydration of alcohols. Okay, so dehydration of alcohols, it leads to the formation of alkene. So if we see one example, then let us say this. So just leave this. For this purpose, an acidic medium is used. So we have H plus. Heat is also required. So in this reaction, if we see, then we get an alkene. Next we'll see some identification tests of alcohols. The first is the sodium metal test. So this particular reaction we have just observed in the previous slides. So in this we see alcohols, they react with metals like sodium and they liberate hydrogen. So hydrogen is liberated. So this we have seen this in this reaction. So this is also one of the identification tests for alcohols, that is called as the sodium metal test. And this particular hydrogen gas which is liberated, it gives effervescence in the solution. The next test is also as the next test is ester test. It's called ester test, which also we have studied, we have discussed just now. This reaction, the esterification. So this is also an identification test called the ester test. Next test is steric ammonium nitrate test. So in this we see the formation of a red colored precipitate. So if we see an example, then let us take alcohol, and for this purpose steric ammonium nitrate is used. Steric ammonium nitrate. So this is 6. So this is steric ammonium nitrate, okay, which will give us the red or pink color complex. So we have cerium here. So this particular complex is responsible for giving the red colored precipitate. So this is the alkoxy cerium compound. So the alkoxy cerium compound which is mentioned here is this. Alcohol, when it reacts with steric ammonium nitrate, it leads to the formation of an alkoxy cerium compound indicated here. The next test is our acetyl chloride test. So alcohols, they react with acetyl chloride to give ester, and in this process we see the formation of hydrogen chloride gas. So if we see an example, we have the alcohol here and we have our acetyl chloride. This is the acetyl chloride. So this gives us an ester. Plus the hydrogen chloride gas. So now what happens is that when this hydrogen chloride gas which is released, okay, it gives white fumes. That is, it gives white fumes with what? White fumes with ammonium hydroxide. So if we take the gas that is formed and if we keep it near ammonium chloride, then we will see the formation, sorry, not ammonium chloride, ammonium hydroxide. Then it gives white fumes of ammonium chloride. So white fumes of ammonium chloride is formed when this hydrogen chloride gas which is released during this reaction, it reacts with ammonium hydroxide. It leads to the formation of this ammonium chloride which is white, or which gives white fumes. So this is also another test for alcohol, which is called as the acetyl chloride test. So whatever tests that we have studied here, these are the identification test of alcohols. Now if we have to distinguish between primary, secondary and tertiary alcohols, then we need a separate test for that. So we will discuss two tests for distinguishing between primary, secondary and tertiary alcohols. The first is our Lucas test. So for this we need Lucas reagent. Now Lucas reagent is simply mixture of zinc chloride and HCl. So zinc chloride and HCl is the Lucas reagent. So when we react primary, secondary or tertiary alcohol with this Lucas reagent, cloudiness is formed. So the rate of this formation of this cloudiness is different for different types of alcohols. If we look for tertiary alcohols, then the cloudiness in the solution appears immediately. But if we take secondary alcohol, then the cloudiness takes about 5 to 10 minutes to appear. If we take primary alcohol with the Lucas reagent, then there is no formation of cloudiness. However, if you apply heat, then your cloudiness will be formed. So this test helps us to identify between primary, secondary and tertiary alcohols based on how much time it takes for the cloudiness to form. So if we see one example, then let us take the example of secondary alcohol. So we have this, and then we'll react it with Lucas reagent. So this gives us the product which is responsible for the cloudiness. So this is one example. Similarly, we can have examples for tertiary as well. So please do it, you can do it as an exercise for the viewers. We'll move to the next test. The next test is called the Victor's-Meyers test. Victor's-Meyers test. So in this test, alcohol it is first treated with phosphorus and iodine. So when we do this, we get an iodoalkane. Now this iodoalkane is again subsequently treated with silver nitrate, and with this we obtain nitroalkane. Now the nitroalkane which is obtained is simultaneously treated with nitrous acid, HNO2. So what happens is that after this we add KOH. We add KOH to make the solution alkaline. As soon as the solution turns alkaline, then we see a color change. Now the color change which will happen in the solution is different for different types of alcohol. So for primary, if we see, then the color obtained is red. For secondary, if we see, then the color obtained is blue, and in case of tertiary, no color change is observed. So if we see the reaction, let us take an example of a primary alcohol. So if we see, then so we have a primary alcohol here which is treated with phosphorus and iodine, and we get our iodoalkane here. Now this iodoalkane is subsequently treated with silver nitrate. So when it is treated with silver nitrate, we get a nitroalkane. Now this nitroalkane is again subsequently treated with nitrous acid, HNO2, and then we get our nitrolic acid here. This is NO2. Sorry for the interruption. So we have nitrolic acid here, and then this nitrolic acid again, when it is made alkaline, or when it comes with when the environment becomes alkaline with the help of potassium hydroxide, then we get different types of color changes. In our case, since we are talking about primary alcohol here, so the color change in our case will be red. So this is one example of the reaction, how it proceeds for primary alcohol. Similarly, for secondary and tertiary, the reactions are similar. So you can the viewers can do this as a practice question. So these are the different identification tests that we have studied, as well as the test for distinction between primary, secondary and tertiary alcohols. So this is the end of today's discussion. So I hope this will be beneficial to you, and You may forward this video to anyone who may need it. And also I repeat again, kindly like and subscribe this official YouTube channel of the Institute of Pharmacy, Assam, Don Bosco University. And thank you so much for your time and attention. We'll see you in another video.